All right, now that you know how to do all these from the practice yesterday, we're going to practice expanding again. Let me just do one with you guys. Actually, let's do this one. This one's a little harder. Number 2. Okay, so before you try to expand, you might want to turn that square root into something with an exponent. So that square root is what? 1/2. So it's x squared plus 5 to the 1/2 over x. Okay, what can we do to expand it? Yes. Okay, so make sure you do minus and not another divide. All right, what can we do next? Okay, move the 1/2 to the front. What else? That's it. Okay, I'm trying to see who gets tricked. So a lot of people will just be like, let's distribute the ln. You cannot distribute a function. Okay, that makes no sense. So no, you cannot do that. Please don't do that. This is it. That's all you can do. You cannot take that x squared, the 2 from the exponent out. That's not okay. You cannot split it. This is as much as you can do. All right, so let's go ahead and have you guys practice 1. And then 3, you want to combine it together. So simplify into 1 log. Number 1, you expand. Number 2, you simplify. Number 1. So we can expand this by adding all the logs together. And this 4, as the exponent, can come to the front. This log 8 can be expanded. So 8 is what to what power? 2 to the 3rd. So then that actually means we can expand that more. So 3, equals to 3 log 2 plus log x plus 4 log y. Number 2. Natural log x to the 5th, and then this has to go on the exponent. Now the exponent goes on everything that's inside. That's the whole xy. So then that's going to be x squared y squared, like that. Please be careful. Natural log x to the 3rd over y squared. So this is another common error where people forget that this exponent goes on everything inside, not just whichever one you want to pick. Next, let's review from last year. Change of base. So let's say you're trying to evaluate this. Now, on most calculators, you cannot change the base, so you need to actually change it yourself. And this is the rule. So if you have a log base b of x, you can change it so that it will be whatever log base you want, and then you put the x here and then the b here. So what does that mean? If you have a log base b of x, let's say your calculator doesn't have a base b, whatever that was, like log base 3, your calculator doesn't have a log base 3. However, it has log base 10 or log base e, right? Those are common 2 logs on your calculator. So you can change it so it's just log x over log b, or natural log x over natural log b. That works, and then you can use the calculator to calculate. So, for example, this one, log base 4 of 7. So most calculators cannot calculate that. Now, if you have the newer calculators, you can change base. You just have to find that button. Let's say your calculator does not have it. Then what you need to do is you need to change the base yourself. You can change it to any base you want as long as the numerator and denominator have the same base. So you can do log 7 over log 4. Notice that the 7 is that 7 inside, and this 4 is that base. And I'm changing it to a common log. Or I can change it to a natural log. It's the same thing. Either way, you would get the same number. I think we did a proof last year, but you can go through a proof to see that why the base does not matter, as long as you keep it consistent. But it's just you just have to remember that this is the rule and it works. Okay, so go ahead and try it and figure out the number. Again, make sure you close the parentheses when you're typing in the logs. Okay, what number did you guys get? 1.4? Good. Let's round it a little more. 1.44. Okay, so let's have you guys try this. 1 and 2. Number 1 is 1.893. Number 2 is 0.565. Okay, now we can do change of base on things that don't actually have numbers. For example, log base 2 of x. And this question says, using only common logs. What is a common log? Log base 10, so just log. So they want you to change it so it's just using logs with no other base. All right, so how do I change this? So, yeah, question. So how do I change this so that it's just using log and not a log base 2? Huh? Like raise like this? We cannot do that. If you want to raise it, there must be another side to do something with, so it's balanced. There's nothing on the other side, so you can't change it. Yes, change the base. How do you do that?
Put log x on top.
Uh-huh.
And then underneath the log 2.
Yes, that's correct. So that's how you're supposed to do it with just common logs. Okay, let's try number 2. This one is a little bit weirder. How do you change it so there is only a common log? Okay, let's have you guys try it with your partner. So go ahead and talk to your partner, do it, and check each other to see if you guys have the same answer. Okay, so Trey and Andy, what do you guys say is the answer?
Log x plus y over log 1 over 2.
Yes. Now we can go one step further. Which is, it has to do with this part. What can we do on that part to separate? So how do we do that?
Log 1 minus log 2.
Yes, log 1 minus log 2. We can go one step further from here. Has something to do with the denominator. Mark, is that a hand or stretching?
Isn't log 1 0?
Yes, log 1 is 0. So that's what you had to see, that this part is just 0. Okay, so this is kind of the final answer. And you do need to get to this point for some problems because they're going to ask you for transformation. And you need to get to the point where you can see that log 1 is 0 so that you can see there's a minus, which has to do with the reflection. Okay, so let's do some transformation. Use change of base formula to rewrite log base b of x using natural logs. Okay, so they want natural logs this time. Determine the transformation from natural log x. Let's do one that actually has numbers. I think it's a little hard. Okay, so practice determine the transformation from natural log x, sketch the transform graph. All right, so they want to change all of these random bases to just natural logs. So how do we do a change of base on natural log, log base 5 of x to a natural log. Okay, so now we need to figure out the transformation. To figure out the transformation, we need to figure out what is the parent function. What is the parent function? ln x. So ln x is the parent function, so then what does this natural log 5 do? It depends. So what we need to do is rewrite this a little bit. This is 1 over natural log 5 times natural log x. So this has to do with what? 1 over natural log 5 has to do with what? Stretch and compress of what kind? Vertical or horizontal? How many people say vertical? How many people say horizontal? We're not sure. Talk to your partner. Vertical or horizontal? So it definitely has to do with vertical or horizontal because it's multiply. The question is which one? How many people think vertical? How many people say horizontal? Okay, the answer is vertical because it's multiply on the outside of the function. If it's inside the function, that would be something like this. That would be horizontal. The question now is, since it's a vertical, the question is whether it is compressed or stretch. That has to do with the number. So you do need to type it into your calculator to figure out what 1 over natural log 5 is. Okay, 1 over natural log 5 is what? 0.621. Natural log x. So this is pretty clear. Is it going to be a stretch or compress? Compress. Yeah, so this is going to be vertical compress 1 over natural log 5. Please be careful. This is where a lot of people make mistakes. They get to this point, they see the natural log 5, they put the natural log 5 in their calculator, and they said it's a stretch. Because yes, that number is bigger than 1. However, the number that's multiplied to the function is 1 over that. So please be careful. Okay, let's have you try one. Number 2. Remember, you're trying to figure out the transformation from natural log x. From natural log x. Okay, let's start with Sherry. How do we change this to just natural logs?
Natural log x over natural log 1 over 4.
Okay, all right. So, Junior, can you tell me the transformation? What kind? Okay, vertical, it's not a stretch because this is going to be natural log x times 1 over natural log 1/4. I believe that number is less than 1. Sorry, between 0 and 1. Yeah, compressed by 1. But what? By what? Sorry.
1 over 4.
No, it's going to be 1 over natural log 4. And then that 1/4, actually we need to split it, so it's natural log 1 minus natural log 4. So then the other part is reflect x-axis. All right, number 3, Blake, how do we change the base so that it's just natural log?
Ln x over ln 1/5.
Uh-huh.
And then you would separate the ln 1 over 5 to ln 1 minus ln 5.
Mm-hmm.
And then you have negative ln 5 in the denominator.
Uh-huh, good.
And then you separate the ln x times 1 over negative ln 5.
Mm-hmm. Good. All right. Allison, what are the transformations? Reflect x-axis. One over what? ln 5. Yes, good. All right, the last thing we're gonna do is, again, another analysis. All right. This says identify the transformation and perform full analysis for this function. Let's say from y equals natural log x, because if they don't tell you, then the question is what is the parent function? It's not clear. So let's say the parent function is natural log x. So you need to do change of base to figure out what is going on with this function. Okay, so we gotta change the base. You guys got this, right? So change base, and we need to expand as much as possible so we can get just the natural log x by itself. So you see there's a 9x there, so we have to do something with that. All right, someone tell me the first step that you took. Okay, change of base. So what did you get? Uh-huh. Uh-huh, good. So that is at least the first step. And then the next step. How do I take the ln x out? Separate it. So natural log 9 plus natural log x. Okay, and then? All right, and then we know that's going to be 0. So we got to natural log 9 plus natural log x over negative natural log 3. Okay, now what? We could stop right there and then try to figure out the transformation, but there is one more step we can take to clearly see the transformation. Yeah.
You do the 9 thing to make it into 2L and 3.
Okay, so 9 is the same as 3 squared, right? 3 squared. And then we can see that this we can move to the front. So we have a 2 natural log 3 plus natural log x over minus natural log 3. And then now if we try to separate it, the natural log 3 would actually cancel. So we would have a better idea of what the transformation is. Okay, so 2 natural log 3 over minus natural log 3 plus natural log x over minus natural log 3. You can see that, right? I'm just separating out the denominator. The natural log 3 is going to cancel. So I have a minus 2, basically a minus natural log x over natural log 3. And if we want to just like really make sure we know what's going on, we can even write it like this. Now it's very clear what the transformation is. Are you guys following? So if you didn't take the step of changing 9 to a 3 squared, you could still do the transformation. It's just, it might look a little strange. I think if you actually type that into your calculator, natural log 9 divided by natural log 3, you should get a 2. But if you start rounding from the very beginning, you might not get a 2. If you kept everything in there, like all the numbers, you should get 2, I believe. Or, yes, 2. All right. So now what is do you guys want to just take a few minutes to figure out the transformation and the analysis? Okay, let's have you guys do that. I'll give you about 3 minutes. So figure out the transformation, analyze the function. What you want to do is probably graph this whole thing so you can see it. Okay, let me rewrite the function up here. Y equals negative 2 minus 1 over natural log 3 times natural log x. Okay, let's start with Eunice. Give me one transformation. Hmm?
Vertical stretch.
Mm. Pick something else.
Reflect over x-axis.
Yes, reflect x-axis. Alana, give me another one. Okay, down 2. Trey, give me the last one.
Vertical compress 1 over ln 2.
All right, Andy, domain. Do we include 0? Correct. Josh, range? It does have a range. If it doesn't have a range, it won't show up. Guess again. How about Evan? Do you know?
Y less than.
Huh?
Y less than -1.
No, not less than -1. How about McKenna?
All real numbers.
Yes. Remember, all of your logs are all real numbers all the time for range. So your graphing calculator is not showing the whole thing. It's stopping here, but it does go straight down. Okay. Ashley, continuity. Yes, continuous. Caleb, increasing interval. Mark, decreasing interval. No, check again.
0 to
Yes, 0 to infinity. Let's do Amelia. Asymptote. No, y equals 0 is this way. Yes, x equals 0. Okay, Sally, give me one end behavior.
X to infinity.
Y
Equals negative.
Yes. And then Aaron, give me the last end behavior. Yes, x goes to 0. Infinity. So when x is going to 0, y is going straight up. So when x is going to 0, y is going to infinity. All right, I think that's it, right? Yeah.